What's the first attraction? It's a magnet.
Hi, I'm Jay Brown from NVE Corporation, and today we're looking at a product demonstrator that shows the differences between NVE's GMR sensors and competing AMR and Hall effect sensors. If you look at the end of the circuit board coming out of the case, you'll notice that 3 sensors are mounted on the end of the board. The top sensor on your screen is an AMR sensor, the middle sensor is a GMR sensor from NVE, and the lower sensor is a Hall effect sensor. The NVE sensor is smaller than the AMR sensor and the Hall effect sensor. Now when we move the magnet closer to the end of the boards, closer to the sensors, there's an LED that comes on, indicates the sensor is turned on, and you'll notice that the GMR sensor has turned on first. As we move this closer and closer, the AMR sensor will turn on, and then finally the Hall effect sensor will turn on. The LCD displays that are next to the LEDs show the current in milliamps drawn by each of the sensor elements. And you'll also notice that the GMR sensor uses much less current, around 220 microamps, than the AMR sensor or the Hall effect sensor, which both use milliamp levels of current. We can also move the magnet to different positions and get basically the same results. If we move the magnet up here, again the GMR sensor will turn on first, and then the AMR sensor will turn on, and in this case the Hall effect sensor is probably too far away and won't turn on. If we move it over and more towards the bias towards the Hall effect sensor side, again the GMR sensor turns on first, then the Hall effect sensor turns on, and the AMR sensor will not turn on when the magnet is in this position. So in all cases the GMR sensor will turn on first and is more sensitive to the applied magnetic field than either an AMR sensor or a Hall effect sensor. So to sum up, GMR sensors are smaller, more sensitive, and use less power than AMR or Hall effect sensors. You can click, email, or call NVE for more information.